Libraries, which are generic, extensible, programmable, and modularized. Note that in this course we will specifically cover the concept related to developing Linux system C libraries specifically, but 80% of the concept that we will going to discuss equally applies to developing C++ libraries also. If you happen to become a programmer, be it in any area, suppose you become a C# programmer, Java programmer, or Python programmer, or programmer in any other language, you will write most of the code using the libraries which have been already created for you by your ancestors. Ancestors means the employees which were working before you in the company. After doing this course, you shall be able to write a reusable code as a library and reuse the library in applications. We will take the example to build a library of doubly linked list throughout this course. So in this course, to explain the concepts regarding how to develop a C or C++ library, we will going to take doubly linked list as an example. The technique that you will learn in developing doubly linked list library is equally applicable to build a library for any other data structure, be it tree, graph, stacks, queues, or any other standard or non-standard data structure. Also note that it is expected that you are aware of C programming, right? And I assume that you already knows how doubly linked lists work. In this course, I will not going to discuss about the fundamentals of doubly linked list. I expect that you know how to insert, delete, or search an element from a doubly linked list data structure. I also assume that you are at least above average in C programming. This course is an advanced course, and this course is absolutely not meant for C beginners. So if your level of programming is such that you still have problems with pointers, arrays, or some basic elements of C programming, then this course is not a good choice for you. If you are at least an average C programmer, then this course will take your programming skills to the next level altogether. So this is a little bit of advanced C programming course. So going forward, so what exactly library is? So probably you must be knowing that what exactly library is. So a library is nothing but it is a reusable code that can be integrated with any application, note the word any application, and hence application can use the library. So for example, the most common libraries you have heard are linked list, stacks, queues, trees, graphs, and many others. These common data structures exist as library in the company code base. Why? Because they can be used again and again by various applications as per the requirement. Right? So for example, a school management system application can use linked list to store the list of students, whereas a railway reservation system can use a linked list to store the details of passengers. Right? So the same data structure, that is the same piece of code, or you can say in other words, a same library is being used by two different applications, that is a school management system and railway reservation system, and the library is being used by these two applications to store different types of data. Right? What is that data? The data is the list of students and the details of passengers. So all languages have their standard set of libraries which developers uses all the time while writing code in that particular language. For example, in C there are standard functions like memcpy, memset, string copy, malloc, free. So these are all standard set of functions which are defined in standard library of C programming language. Right? So the name of the standard C library is glibc. So a library is nothing but a library can contain reusable functions, right? For example, finding the square root of a real number, right? So you can see that this function seems to be very generic, and any applications may wish to find the square root of a real number, right? A library contains constants, for example, number of hours in a day, or it can contain enumeration constants like Sunday, Monday, Tuesday, and so on, right? And library contains macros. So macros are nothing but these are the shorthand of some complex expressions. So we use macros to simplify the expressions while writing a code. For example, square x is a macro which expands to compute the multiplication of number by itself. So in the application code, you can simply write square x instead of writing x into x. However, this macro looks fairly simple, but instead of x into x, it could be some complex expression which you would not want to write again and again in your application code, right? And libraries are generic. Note the word generic. Generic means that they do not assume that they have been written for some specific applications, right? Libraries are supposed to be generic because at the end of the day, libraries have to be used in the context of any application. And libraries cannot assume that they have been written for some specific applications. So we will elaborate this point further. So let us try to understand the relationship between a library and an application. Maybe this point is very obvious to you and you fairly understand the difference between library and application. So we will go a little bit faster in discussing the basics of this course, that is what is library and what is application and so on. So you can see in this diagram we have a linked list library and we have three applications, that is application 1, application 2 and application 3. And you can see that all these applications are making use of the same linked list library. That is, the same code is being used by all the three applications, right? So application is nothing but it is a consumer of library, or in other words, it is a user of library. Application uses the library to organize and manage its internal data structures, right? So for example, application may need to use heap library in order to perform Dijkstrah calculation on a data organized as graph using graph library, right? So you can see in this example that an application is using two libraries, the heap library and the graph library. The application is using graph library to organize its internal data structure in the form of a graph, right? But application also wishes to run shortest path first algorithm on this graph. And in order to run shortest path first algorithm on the graph, the supporting data structure that the application is using is heap. So application also needs to use heap library. So you can see that library is a pre-written code that actually resolves some specific problem. So a library is write once and use everywhere code. That is, you will going to write a library code only once and then you will going to import that particular library into your applications and use the library code in all those applications as per the requirement. So going forward, in this course we shall apply the concepts of designing and writing a library using linked list as a sample library example. So here linked list means doubly linked list. It is expected that you know the functionality and operations of doubly linked list, such as insertion of data in the linked list, deletion of data from the doubly linked list, searching of a particular data in a doubly linked list, and traversal on a doubly linked list. So these are the basic operations that one should expect to perform on a doubly linked list. By the end of this course, you should be having a fully working doubly linked list code as a library. So let's begin our journey step by step. So fasten your seat belt, guys. Good luck. I assure you that you will going to thoroughly enjoy this course, and this course will take your level of C programming closer to the level of professional programmer. So guys, I have prepared this special lecture regarding setting up Linux development environment on your local machine. So for those who are familiar with the Linux and those who are already using Linux for some time now can skip this lecture. I have prepared this special lecture only for those students who are not familiar with the Linux and they will be learning on the Linux operating system for the first time as a part of this course. All the coding assignments that you will be doing in this course will be done on Linux operating system. So here I have given this checklist. So make sure you have exercised all these points which are mentioned in this checklist. So what are all the softwares that you need? You need to install the software called VirtualBox and you need to have a Linux operating system. In this course I have used Ubuntu 14.04. So if you are using Linux operating system for the first time, I would recommend that you use Ubuntu 14.04. I recommend you to use the same Linux distribution as mine so that whatever changes or configuration I do in my operating system, exactly same changes you will also need to do in your operating system. So you would not have to break your head on the internet trying to figure out how to do the same thing in your Linux distribution. So I would recommend you, if you are absolutely beginner of Linux operating system, then use the same operating system as mine. And we will be using the Git for all your projects and assignments. So what is Git? That I will explain. So all the steps of this checklist I have mentioned in this YouTube. I will share the URL of this YouTube in the resource section, so don't worry. All the softwares to be used and all the installation steps that is required to install those software are actually explained in pretty much detail in this YouTube video. So let us go through this checklist. So you should have a working laptop and your host operating system could be any operating system, but I assume that your operating system is Windows. So host operating system is an operating system which comes with your laptop when you actually purchase the laptop from the shop. Right? Now you need to have a virtualization software. That virtualization software I would recommend to use as VirtualBox because it is free. Now what is the use of this VirtualBox? This VirtualBox software will allow you to install another operating system on the top of your host operating system. That is, you can install as many operating systems as you want. So as a part of this course, using VirtualBox software, you need to install the Linux operating system, which is Ubuntu 14.04. So you will have Ubuntu 14.04 installed in your virtualization software. So the Ubuntu operating system that is installed on your host operating system using virtualization software is called virtual machine. So test internet connection from inside your virtual machine, which is actually Ubuntu operating system, by pinging to any public website, say www.google.com from terminal. Right? So if you are able to ping, it means your virtual machine is connected to the internet. Then you need to have certain software installed on your virtual machine, such as Vim. So Vim is an editor in which you will do all your programming assignments. Git, you need to install Git on your virtual machine so that you can access all the Git functionality through the command line or through the terminal. Then cscope is a small piece of software which helps you to navigate through your source code very easily and fast. And screen is just another small software which allows you to open multiple screens on your terminal window. Right? So it is advisable but not necessary to have all these software installed on your virtual machine. Then step 6 is very much optional. Either you do it or don't do it, it's up to you. It's just that if you practice the step 6, then you can log in into your virtual machine directly from your Windows host operating system. So for that you need to have a MOBA XTerm to be installed in your Windows operating system. I have explained the steps of installing the MOBA XTerm and the settings that you need to do in order to log in into your virtual machine from your Windows operating system. And step 7 is actually important these days. You need to create a GitHub account and you need to do all your coding assignments and upload all your assignments on your GitHub account. So it is very important to have your GitHub identity because your GitHub account when maintained properly and when you have your projects and assignments regularly updated and uploaded on GitHub account, then the employers will conclude that you actually work very regularly and you are good at coding or various other stuff. So basically your GitHub account speaks on your behalf and it showcases all your work that you have done to the employers. So please take this GitHub account very seriously. And this YouTube will guide you through all of these 7 steps that I mentioned in this checklist. Thank you.
If you read his mail and see me.
In this course, we will going to understand the concepts related to implementation and designing a good library. So for that purpose, we will going to implement our own library called W-linked list library. So to start with, you can download the source code from this URL using git clone command, and inside this directory, please go inside the directory lib file organization. So you can see that I am already in this directory, that is lib file organization. And in this directory you will find dll.h and dll.c file. So let's see what is there in dll.h file. So DLL stands for W-linked list. And on the right hand side I am opening the file dll.c, that is source file. So you can see that I have a source file on the right hand side. In this course, we will going to understand the concepts related to implementation and designing a good library. So for that purpose, we will going to implement our own library called W-linked list library. So to start with, you can download the source code from this URL using git clone command, and inside this directory, please go inside the directory lib file organization. So you can see that I am already in this directory, that is lib file organization. And in this directory you will find dll.h and dll.c file. So let's see what is there in dll.h file. So DLL stands for W-linked list. And on the right hand side I am opening the file dll.c, that is source file. So you can see that I have a source file on the right hand side and header file on the left hand side. So we will going to implement the W-linked list as a library in this course. So you can see that in the header file on the left hand side, I have the structure definitions defined. The first structure defines the node of a W-linked list, and the second structure defines the W-linked list itself. So of course the W-linked list needs to have a pointer to the head of a W-linked list, right? So this is the structure definitions, and because this structure definitions needs to be shared across several source files which wishes to make use of W-linked list utility, therefore these structure definitions needs to be specified in the header file. Now related to this W-linked list, there are 2 functions which have been declared in this header file. The first function is getNewDLL, which returns a pointer to an empty W-linked list, and the second function is a function which allows you to add the application data to this W-linked list. So you can see on the right hand side we have a source file, and the first thing that we do in the source file is to hash include all the header files on which the source file is dependent. So you can see that in this source file we have actually implemented the logic of functions which were declared in the header file. That is, we have actually implemented the logic of get new DLL function, as well as we have implemented the logic of function add data to DLL. So you can see that the function definition should be present in the source file, whereas function declaration should be present in the header file. So it is an assignment for you. Just do not watch my codes. Start implementing your own version of doubly linked list library. So you create your own header file and source file and provide the implementation of some functions in your doubly linked list library. So of course you should try to implement more functions. This course assumes that you are already aware of fundamentals of doubly linked list. So guys, going forward, I expect you that you have written two files, that is dll.h and dll.c, and provide the implementation of at least these two functions which we have discussed. Now it is time to see our small library in action. So for that purpose, go to the directory application integration. Now if you go to this directory application integration, you will see application.c file in addition to dll.c and dll.h file. So application.c file is a file which actually represents our application, which make use of doubly linked list library that we have just written. So if you see the implementation of application.c file, it's fairly very simple file. You can see that in this main function we are actually creating certain objects. In this example, we have taken person_t as an application specific data structure. So it has three fields, which is name, age and weight. So remember, it is application specific data structure and we want to create objects of this structure using malloc or calloc system call, and then we make our doubly linked list library to hold these objects. So you can see that after creating three objects in the main function, that is person1, person2 and person3, I am actually now creating a doubly linked list. And after creating a doubly linked list, I am actually adding these three objects to our doubly linked list. So you should now verify that our doubly linked list is actually capable to hold the application specific data. So for that purpose, I have written a function print person database. So persondb is nothing but it is a name of a doubly linked list which holds the record of type person data type. So print person database does nothing, it simply iterate over the entire doubly linked list, and for each node of a doubly linked list it actually prints the data which is held by the node of a doubly linked list. Right? So fairly easy, simple example. Also one thing to note here is that application.c source file must hash include the dll.h file, because in this source file we are actually using the functions which have been declared in this dll.h header file, right? Now in the next step, let us see how to compile the program and run it on Linux platform. So you can see in this slide, you should always be able to compile a source file independently. So in our case, we have two source files, that is application.c and dll.c. So here is the command that is written in order to compile the source file. Just type out these commands on the terminal and you should be able to compile the source file. So gcc here is the name of the compiler. -g is a flag which we will discuss later. -c is actually used to specify that you want to compile a source file, and -o flag is used to actually indicate the name of the output file which will be produced after compilation. So probably it is very basic thing for you, but I am assuming that not all the students have ever worked on Linux platform, and therefore I have to explain these things in a little bit detail. So if you already have a background that how to run and compile C programs on Linux platform, you can actually fast forward this particular lecture. So I expect you to try out these commands in the terminal and see that you should be able to compile application.c and dll.c source file. So after compilation you will have the two object files, that is application.o and dll.o. Now the third step is the step where you will actually create a final executable. So final executable is what you will finally execute and see the output of a program. In order to create an executable, you need to run this command, that is gcc -g, and specify the name of all the object files. So in this case we have two object files and -o exe. So exe is our executable which will be produced. So exe is our executable which will be produced by this command. And once you have exe, simply run the executable by using /exe. So you can see that the first two steps are called compilation steps, that is you are in the third step is called the linking step, that is you are using all the object files together to create a final executable, and the final step is the step where you actually run the executable. In another module of this course, we will see in detail that what happens when you actually compile a source file and what happens when you actually link all the object files together in order to create a final executable. So compilation and linking are actually two separate processes, and we will going to study these two separate processes in detail. So guys, going forward, and let me summarize that what we have done so far. So far we have created a very mini doubly linked list library which contains a header file and a source file. And we have an application.c file which wishes to organize its internal data structures using doubly linked list. So because application.c file wishes to make use of doubly linked list utility, the functions and definition of doubly linked list needs to be exposed to application.c source file, and therefore it is for this reason that application.c file needs to hash include dll.h file, right? Now after that we compiled the source files. So here, after compiling the dll.c file, we got the object file dll.o, and after compiling the application.c file, we obtained application.o. So remember, object files are not human readable file. They actually contains the source code in the machine instruction form which you cannot read. So once you have all the object files for all the source files you have in your project, we then combine all the object files together to create a final executable. So remember, final executable is created using all the object files that you have in your project. But one thing need a mention here is that exactly one of the object file must be derived from the source file which contain the main function. So in this case it is application.c source file which contain the main function, because execution of a C program starts from main, and therefore to create an executable it is a requirement that one of the source file must contain main function. And we have used the GCC compiler, which is Linux standard C compiler, to compile our source file as well as to link our object files together to create a final executable. So the command to compile the source file is this, And the command to link all the object files together to create a final executable is this command. We will discuss in more detail in one of our future module that exactly what happens when you compile the program and exactly what happens when you link the object files together to create a final executable.
You are aware of anything to do with virtual machines, or no? Are you aware of containers, or no? Like
So welcome back guys. In this module we will going to learn exactly how header file works. So if we understand exactly how header file works, we shall be able to save ourselves from various compilation errors. We shall be able to organize and design our projects better. That is, we will be able to organize our header file and source file in a better way. I have seen even experienced programmer who have experience close to 4 years are not clear about how exactly header file works, right? So therefore I have decided to include a topic on header file altogether in this course. Header files are non-compilation units. So remember the term non-compilation units means that compiler do not actually compile the header files, right? So remember header files are non-compilation units. But you still see syntax error if you write something wrong in the header file. So if you see syntax error, it simply means that compiler parses or compile the header file also. Now it is something that is contradicting with my first statement that header files are non-compilation units. So we will understand this point when we will know exactly how header file works. Now, coming to the inclusion of header files. Inclusion of the header file means hash including the header file in your source file. Now, if you have ever written a C program, you must have hash include standard or non-standard header file in your C file. So hash including the header file in a source file is called inclusion of header file. Now, inclusion of header file simply works by following these three fundamental steps. The first one is the recursive text substitution method. In the second one, simply replace the hash include header.h statement by the content of header.h header file. So if in your source file you are writing a statement such as hash include header.h, so during the compilation process, the compiler replaces this entire statement with the content of header.h header file. Now the question arises that header.h header file itself can contain other hash include statement. Now if this is the case, then simply replace the nested hash include statements by the content of the respective header file. So hash include b underscore header.h statement will be replaced by the contents of b underscore header.h header file. So you can see that the replacement of hash include directive by the corresponding header file is recursive in nature. We will going to understand this point with the help of an example more elaboratively in the next slide. Now these 3 points, that is recursive text substitution method and replacing the hash include directive with the corresponding header file content, help us to achieve these 2 basic principles of C and C++ language. The first one is that define the structure definition first before use. Let us call this principle as define and use thumb rule. And the second principle says that declare the function prototype first before use. So let us call this principle as declare and use thumb rule. So you can see that first thumb rule is specific to structures, whereas second thumb rule is specific to functions. We will going to have a discussion on these 2 thumb rule in detail in the coming slides. Now let us discuss in detail that how the inclusion of header file in the source file actually works in detail.
So this is the operations that you perform now to which now you will be doing the operation.
So welcome back guys.
So I want to ask
In
you,
this module we will
what
going
you
to
want to know
study that how should one plan his or her project and how should he organize his project files in the form of header file and source file. So in C or C++ we usually organize our code whether the code represent an application or whether the code represent a library. We usually organize our code in two types of files, that is header file and source file. Now the clear question that arises is that what should be the content of header file and what should be the content of source file. So header file usually contains anything which needs to be exposed to other source files. So just remember this mantra. Header file should contain anything which needs to be exposed or shared by several source files. Now that anything could be structure definitions. They could be constants or enumerations, macros, function declarations. Now remember, header file must contain function declarations of those functions which needs to be shared among several source files. Now if you have a question that what is the difference between function declaration and function definition, so let me explain that whenever you declare a function, you just write it like this. It is function declaration, whereas function definition means that you are also specifying the logic of the function. This is called function definition. So header file contains only function declaration and header file never contain function definitions unless the function is an static inline function. So in case of header file, just learn the mantra that anything which needs to be exposed or shared to several other source files, then that particular things needs to be specified in header files. Now coming to the source files, actual implementation of logic as functions whose declarations are present in header files. So in source file you should specify the function definition, that is actual implementation of logic as functions, right? So this thing that is function definition usually becomes a part of source files. So in case of source files, just learn this mantra by heart. That is anything which need not to be exposed to other source files is always specified in the source file. So you can see in this diagram that header file is actually a content provider to source files. Header file simply says that, hey source files, I have this following information for you, please use this information. Now that information could be structure definitions, it could be constants or enumeration, macros, function declarations or static inline function. C files or source file hash include the header files. By hash including the header files, C files actually inherit the information from the header file, and that information then becomes a part of that particular source file. So source file simply says that, hey header file, thank you very much, we will use what you provide to us. So for example, if suppose this header file contains the structure definition S, and suppose there are three source files which actually hash include this particular header file, then this structure definition S will be inherited by all these source files. It means that the structure definition S is defined 3 times in 3 different source files. Same goes with every other type of information, be it constant, enumeration, macros, function declaration or static inline functions. So this is the relationship between header file and source files. Now going forward, I see that often students find it difficult to understand the purpose of header file. Therefore, I have put in an extra effort to actually try to explain the concept and purpose of header file. So header file simply says to the developer means a programmer who is using the header file which is written by somebody else. Header file simply says to the developer that, hey developer, I have the declaration of all these functions whose definitions is defined in some other source file. Use them using the prototype or signatures that I am telling you, and yes, do not dare to see the internal implementation of these functions in source files. So the entire essence of the header file is captured in this dialog. A header file conveys that what is there to be used by you, and you should not bother how it is done. A developer of an application who wishes to use doubly linked list in his application must need to have an access to dll.h file. Now dll.h is a header file of doubly linked list, right? So if a developer has an access to dll.h header file, he can hash include this file in his application code. And after hash including this dll.h file in his application code, a developer can make call to functions which is declared in this header file. Remember, the definition of those functions has to be present in the corresponding dll.c file. So developer do not need to see what is there in dll.c file. So it is equivalent to like eating a tasty pre-cooked meal without knowing how it was cooked. So all information that developer need to have is to make use of doubly linked list library in his application without actually worry to know how that doubly linked list library internally works. In fact, you use it all the time. In the simplest C program that you have ever written, you also hash include standard header files like stdio.h or memory.h. So by including these standard header files in your application, you are actually using the functions whose declarations are present in these header files without actually worrying the internal implementation of those standard functions. Have you ever bothered that how malloc function has been implemented? Right? You have never bothered. You have never bothered that how free function or printf function has been implemented. Right? So this is the purpose of header file. That is, make things available to you without letting you worry about how those things were built or implemented.
एग्जाम्पल फोल्डर क्यों बनाया अगर सॉकेट फोल्डर उसके बाहर बनाया सोचे प्रोसेसिंग
डेटा एक ही फिक्स हो गया ना सर, चेंज ही नहीं करता।
कॉन्फ़िग फाइल लो, कॉन्फ़िग फाइल में से रीड करके जाओ और फिर रियल टाइम में आईपी चेक करते हो और वो स्लो करके चेक करते हो फिर कॉन्फ़िग फाइल लो ना, उसमें से रीड करो और उस कॉन्फ़िग फाइल को बटन पे करो
आ गया ना।
चलो दो ली
और कोई तरीका होता है?
चेंज करना उसको पुश करना है
कोई तरीका होता है? पर HTTP काफ़ी कंज्यूम करता है ना।
क्या नहीं ना HTTP तो रिमूवल है पैकेट खोए तो भी उसको कुछ नहीं
HTTP वापरता है ना।
बीच में पुश करना था ना,
क्या हुआ था?
तो पुश करना था ना, वैसे ही बोला था कि
चेंजेस करके पुश कर रहे हो?
अरे चेंज तो कर दिया,
कोड अपडेट भी करते हो?
लेकिन अवंती ने बोला था कि चेंज करने के बाद इसको बिग चेकआउट नहीं करता है।
चेकआउट से
अवंती ने बोला बिग चेकआउट करते करते
चेंजेस तुम्हारे जिस तरह से उसी से दिखा वो चले जाएंगे। पहले चेकआउट करो फिर चेंज करो।
रुको भाई, फास्ट है तेरा गिने स्टार्ट कर दो, ये ना करो एक ही तो है, एक ठीक है, तो बिग चेकआउट डेवलप ब्रांच को ठीक है, जरूरी थोड़ा है कि ऑटोमेशन टेस्ट यहाँ पे आगे ये चेकआउट नहीं कर सकते हैं। डेवलपमेंट से ना वो बोल रही है कि 30 का कोड के अंदर जाके डायरेक्टली वो कमेंट के अंदर जाके सीधी ऑटोमेशन टेस्ट के अंदर एक सेकंड अब ये क्या हुआ, जनरेटर डी वाई नहीं आता कुछ
अपडेट करता हूँ।
चेंज करना जाओ
ये अपने जनरेटर रन कर रहा है ना, ऑटोमेटिकली वो अपडेट कर देता है।
चेंज क्यों करना है पूरा अवंती देख, मैं तूने बोला था मैं इसको क्लोन करना, मैंने क्लोन किया, ठीक है, क्लोन करने के बाद डेवलप ब्रांच पे, ठीक है, अब मैं चेंज कहाँ करूँ कोड में, कहाँ पे चेंज करूँ मैं, ये मेरा फाइल करेगा,
नहीं यूजर कोड में चेंज करते हैं।
कहाँ पे जाके चेंज करूँगा ये तो बता।
Now we will discuss what exactly text substitution is. So text substitution happen in source file. What are source file? The file with the extension of .c and .cpp are the source file. So text substitution happens in source file which is being compiled by the compiler. Compiler, before actually commence the compiling of the source file, it performs text substitution. Now this point is actually very important. First of all, remember that text substitution happens in source file. Text substitution do not happen in header file. Compiler make use of header file in order to perform text substitution in source file. And second point says that before the compiler actually starts compiling the source file, compiler actually performs the text substitution in the source file that is being compiled. Now, this text substitution is actually accomplished by two pre-processing directives. The first preprocessing directive is hash include and the second preprocessing
अरे
directive
वेब पैक
is hash
मैनेजर के
define.
कौन से
So
component
remember
build
in
करने
C
होते हैं?
or C++,
मुझे वेब पैक
any
मैनेजर
statement
replace
which
करना
start with hash
और कौन से
is
component
actually
build
called
करना होता
preprocessing directive. Why it is called preprocessing? It is called preprocessing because these statements are executed before actually the compiler starts compiling the source file.
मैनेजर का कोई आइडिया नहीं
Now, as we know that hash include preprocessing directive is used to include the header file in the source file. So these 2 points actually tells that how hash include preprocessing directive works. So if in your source file if you have a statement hash include a.h,
यहाँ पर
then
web app
this
manager
statement
3
is
है, web app
replaced by the
manager
contents
1
of a.h header file in that source file. Similarly, if contents of a.h header file in turn contains another hash include statements, then this nested hash include statement is again replaced by the content of that corresponding header file in that particular source file.
लेटेस्ट होगा तो वो यूज होगा
So don't worry, we will going to see how it happens with the help of an example. Now coming to the hash defined preprocessing directive. The hash defined preprocessing directive is used to actually define the macros. For example, here we have a very simple macro in which we define the statement square x as the multiplication of two x values. So in your source file, wherever have you written this square x as a statement, that square x calls will be textually substituted by the definition of the macro, that is x into x, at all the places in a source file. So here I actually expect you that you are familiar with hash defined preprocessing directive. Now let us see how hash include and hash defined preprocessing directives actually work in the text substitution phase with the help of an example.